All right, class, welcome to Wednesday. Da, 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 da. We have two more problems to finish up from last section, and then we do want to jump to the new section, and hopefully I'm going to push to maybe get done. I do have to give you guys a study guide for the next test. Have I given you guys a study guide for the next test?
No.
Good, it'll come today. All right. So I'm thinking, let's see how today goes, and then from there we'll kind of get to know where the test would be here. If we finish up all the next section, I see tests like Monday or Wednesday of next week.
What now?
Say again?
3.4, yeah.
Right, yeah, so we have to see how things go today, and then after that, I should give you guys a study guide. So study guide coming by today or tomorrow. So maybe like Wednesday-ish test probably. So a week from today. All right, this one right here, this is a calculator exercise for you guys. Have to compare these three numbers together, and it is really much of a calculator input issue. And so I do want to show you, I should show you on, I'll show you on the screen here. I gotta show you here. So careful, because we had one student, we will mention who it was.
It was me.
Okay. When they punch this into the calculator, they punch it in like this, log, so careful, especially with your parentheses. So log base 70, if you leave no parentheses here, and you just go like this, what's gonna happen, technically what you're doing is you're doing this right here. Good, without the parenthesis. Does that make sense? You're kind of sticking in square root of 70 is on top. You're making this to be the fraction, and then you take the log of it, and that's not correct. We good? What you want to do is you want to make sure that you have those extra parentheses in here. So when you punch in log, you should get a parenthesis. You're going to punch in the square root of 70, and some calculators, the TI-84s, they string out the square root all the way through. So if you have a TI-84, you want to make sure that you click arrows to the left because you want to close off, and that parenthesis should cover like this. If you see something like this on your calculator, like something like this right here, where it actually did this, that means the parentheses inside the square root, and that's not what you want, right? You want that parenthesis to be out on the outside. And so you finished off that log sequence. Then you divide by log of, and then again, close off that parenthesis. Anyways, guys, go for it here, please. What did you guys get for this answer? And let's see if we agree as a class.
Log 7 over 30?
Yeah. 1.09? Real quick raise of hands if you did not get that. Going once, going twice. Okay. I think this one's the easier one here. This is, let me erase all this. Boom. Okay, this one's just going to be log. This one's the easy one here. It's just log parenthesis 35, log parenthesis 7. And what is the answer to about 2 decimal places?
1.82. Oh, 1.82.
1.82. All right. Anybody did not get 1.82 by a calculator? Because that's what this is, just a calculator exercise. Okay. And then this one, it's going to be 1/2 or 0.5, whichever way you want to write it on the calculator here. It's going to be plus, and then you're going to have to do this little log of what? Square root 10 divided by log 7. And what did you guys get for the last part? 1.091. Ooh.
Well, no, the one, they were the same.
This one is the same as this one?
Yeah.
Whoa. Are we good? Exactly the same digits all the way through?
Wait a minute, that can't be right, it's different.
You have.
Yeah.
His log, his.
Oh, it's plus 1/2. I forgot that.
I have no clue why they're the same, except that they are the same.
That's cool. Okay.
Calculator says so.
So calculator says these guys are the same, right? And I think we have an answer. So you guys talk to me. What's the answer for them both to be the same? No one wants to say it. They said it. You guys said it to each other. Just don't want to say it to me. I feel offended.
What are we saying?
How come these guys? A calculator says these guys are the same.
Because log, or his radical 70 can be written as radical 7 plus, or radical 10 Or
Okay.
sorry, Radical 7 times radical 10.
Oh, that's right. Okay,
And
so
when you
this
have
guy,
multiplication, you can just turn it into addition of the two different properties, the weird rule thing. And radical, or log 7, radical 7 is just 1/2. So then you get log 7 radical 10 plus 1/2.
log 7 and radical 7. Yes, so I'm gonna just do it this little
Log
1/2,
base
stick it
7.
out in front.
Same things.
Base, base 7 of 70. Are we there? Is that good? Everybody okay with that? Agreed with that? And then we split this off. Now, when you split it off, notice that this is just one single piece, right? It's one single log. I'm going to split off into two different logs. I have to put parentheses here. So it's parentheses of log of, oh, that's 7 times 10. So log base 7 of 7 plus log base 7 of 10. Are we good there?
Okay, 7 of 70.
And you distribute the 1/2 back in. And this guy, log base 7 of 7 is just 1. Nice. This becomes a 1/2 over here. Log base 7 of 10. And then this is just 1/2 nicely. And this one becomes the, notice we're using the power rule. We actually pushed it forward, right? And now we're pushing it back in, right? Because you can go which way you like. It doesn't matter.
And then it's square root of 10.
And that's just the square root of 10 again. Boom and boom. Okay, jamming. Let's keep on going here. I'm going to write things out as we go here. So 3.4, the last section, what we're trying to get to is just to solve this stuff. So we have two different types of equations to solve. One is called exponential, and the other one is called logarithmic. And make sure I spell it correctly, logarithmic equations. Boom, we learn how to, let's see, we define them, we learn how to simplify them, we learn how to graph them, and now we're going to learn how to solve them. That's exactly what we do in algebra. We do it with a whole bunch of stuff. We did it with linears before, we did it with polynomials. And next year, you guys get to do it with trig functions here. Again, same thing, define them, simplify them, graph them, solve them. Essentially, that's what we do in algebra for this stuff here. Okay, so let's jam. We are going to solve, and let's start simple. And I'm just going to give you a whole bunch of equations to solve. We're good? And we'll just keep on going at it here. Can we solve these equations here? And start off easy, work our way up to more complicated problems here. So 2 to the x is equal to 32. That's something that, have you guys seen this in Algebra 1? Did you guys see something like that in Algebra 1? Solving exponential equations. So if we have 2 and we have a 32, the question really becomes is this. First things first is, can I make 32 in terms of base of 2? What is 32 with a base of 2? Thinking to yourself. Yeah, to the 5th, huh? Because 2 times 2 is 4. 2 to the 3rd power is 8. 2 to the 4th power is 16, because you're just doubling, right? So 2 to the 1st power is 2. 2 to the 2nd power is 4. 2 to the 3rd power is 8. 2 to the 4th power is 16. Voila. There it is. So if I can get the same base like this, I am done. Those are the super easy ones. Because then what I'm going to do is I'm actually just going to drop my base. I drop my base and I'm thinking, okay, hold on. If the base is the same, that means I'm going to have, the x has to be a 5 because that's the only way it can work out. What exponent do you put on 2 to give you 2 to the 5th? It's 5. Well, the same thing happens with logs. So example number 2, here it is, log of x. We can do this one here, so equal to log of 3. Oh, sorry, ln of x. So I'm going to give you a whole bunch of ones here as we go through them here. Cool. So again, what do we know? X is 3. Easy ones here. There it is. It allows us to cancel off, so we can cancel bases. And we can cancel logs as long as they are on both sides. right? And they're both exactly the same base or exactly the same index to your log or base of log. Are we good? So then the question comes up, hold on, if that's the case, wait a minute. If I can cancel bases, can I stick bases in? Or if I can cancel logs, can I stick logs back in? And I should be able to because the equal sign became an equal sign, right? I'm not adding anything new to the problem. I'm just changing it to a different form. So example 3, let's take a look at that one. Boom, this one. So thinking to myself, X, and what's the easy one here to do? Okay, there we go. Now notice I do have a base of E here. So in that case, I want to use a very specific log, not just log base 10. I want to use, is that Camille coming?
Yeah, she's got it.
So notice this, I don't know what this is. E to the what power gives you 7. Notice that my bases are different from each other. It's not a 7 over there. So what I'm going to do, I'm going to put in log, but I want to use a specific one in order to get rid of E. Boom. Are we good there? Uh-huh. So what happens to the X over here? Oh, do we have any? Let's see, we have 2 different ways we can go. Come here, come on in. Oh yeah, you were on the list already.
What's wrong with the seating? I don't like it.
Me too. So class, real quick, one of 2 ways here. Camille, you doing okay? Ln of e to the x. Do you guys know what that is? Is there a property that does that? Anything?
Can't you bring the X into the front?
Oh, okay, hold on. I was thinking about that. So x goes in front. So you got ln e. And what happens to ln e?
Equals 1.
And this cancels off to give you just 1. Okay. 1, and then just we have x by itself. So that's one way to do it. So off to the side here, let's do it. This will be the first way we do it.
Would this be still equal X equals ln7?
That one, this becomes, some people, what they do is they just cross that out completely like that. You can do that as well. You can just say that's just multiplied to 1, and x is equal to ln7. No problem, done. The other way to do it. Do you guys remember this property? Way back when, from a long time ago, called 3.2. So if we know that property, guess what? Ln e to the x just becomes x is equal to ln7. So a little bit easier. So this one is called using the product rule, right? Multiplying in front and then cancellation. This one is just going back to 3.2 and using the cancellation rule. Any which way is going to work just fine. You know, good. You're going to just go by osmosis. Okay, soaking it in the logs. Okay, go for it. Okay, are we good with 3? Does that make sense? We can add in ln's, we can add in logs to any kind of problem that we need in order to solve it. So let's go back real quick here. Number 1, why was number 1 so easy to do? Common sense, and they had the same base. Once you have a same base, awesome. Then you can cancel, you can go on. The problem here is on this one, we may just not have the same base. So this is going to be 2 to the x. I'll just still give you the same one. How about 42 instead of 32? All right, can we change 42 to a base of 2? Because remember, they're very specific, right? It has to be 2 to the 5th power is 32. That means 2 to the 6th power, if that's true. But the next one you go up, that gets you 64 already. Bummer. Yeah, somewhere. So their answer actually should be between 5 and 6. So at least we kind of know at least a little approximation. Okay, so here it is. What can we put into problems? Logs. Let's go for it.
Log 2 of 42.
Hold on. So this is a log of 2 here, right? Oh, sorry, this is a base of 2. We generally don't put log base 2 into it. We either put ln's because e is sitting there, or we just generally put log. Why do we put log base 10? Any ideas? Why do we put a log base 10 in here? Yes, it is because the calculator button has log base 10. That's it. So what happens here? Now this one we do have to do the power rule. That x has to go out in front. Goes out here. There it is. And then all yours here. What should we do to solve for x? What do we do to solve for x? Perfect. Yeah, we just divide by log. We can say log 2, log base 10 of 2 is fine. That cancels off, and we are left with that. Now we do have to punch. This would be the exact answer. And let's see what your book does. It says round off to 3 decimal places. So now I need your calculator here. So log 42 divided by log 2. Round to 3 decimal places.
5.393.
I agree with that.
Awesome. And yes, and it is it's between 5 and 6, which is what we thought of in the first place. Okay, can we do alternative way of doing it? Because that's the normal process right here. Sometimes you can kind of see it, and it says, you know what, can I change? No, we won't go into that one. It'll confuse you. Let's jam. Exercise 5. Okay, let me let you guys do one like that, very similar, that you guys can practice on as we go. I'll throw in an extra little piece in here. Let's see, can I? Yeah, we should be able to still do that. Okay, so how about 3 to the 2x is equal to 80. All right, I'm going to go with what? Log on this side, log on this side, 2x log of 3. All right, and question, what do we divide by to get x by itself? Ooh, something else as well. And the 2, because I want to cancel off the 2 here, and I also want to get the log 3 out of here. So 2 log 3, so what in the world? As you punch this in, kind of careful as you punch it in, and we'll take a look at the punching in process here. So let's play a little bit this one. So what did you guys get for the answer? 3 decimal places. Point 451. 454. Okay, let's turn this around. Let's play with our calculator just for a little bit here. How did you guys plug this in? Parenthesis, parenthesis, right?
Yeah.
Then?
Divided by 2. And then I did parentheses.
Ah, okay. Did you stick a two parenthesis in on the bottom like this?
Yeah.
Okay.
Yeah, let's see. Everything. Oh, wait, no, I did not.
No, okay. Interesting. Okay. So you got log of 80 divided by 2 like this.
Yeah.
Just want to see what was done here. Okay, so this guy, the way it's converted. Oh, let's check real quick here. Let's check. Can you guys punch in into your calculator? Punch in 3 to the power of 2 times 0.454. What does that give you? See? Oh, bummer. That does not give me 80. And that's no fun. So how about this? In order to keep this whole entire thing in the bottom, it's kind of like, do this on the calculator real quickly here. Do 5 divided by 4 parentheses, 3. Let's see how that works. What do you get as an answer? With the parenthesis on the back end of 4? 3.75.
Yeah, 3.75.
Yeah, so what's happening here is that what you do is, because the parenthesis is not holding all this together, it's only holding 3, but in a sense what you've done, you've done that. You've done 4/5 times 3. Good. So to keep the 4 and the 3 together, like Landon did, somehow, the parenthesis has to be around the whole entire denominator. So if you do it like this, 5 divided by, open up that parenthesis, do 4 times 3, close that parenthesis. Now do you have point something something or other?
1.994.
So for this one, you guys already corrected everything. Okay, cool. So as you punch in the calculator, you have to put an extra parenthesis here, 2 log, close up the log parenthesis, close up the denominator parenthesis. Okay, so now, sorry, Abe, say that again. You got
1.994.
994. Perfect. Okay. Boom. So to check your answer, let's go real quick here. Punch it back in. 3 to the power of parenthesis 2 times 1.994, or you can just say 3, right? Or 2 times 2.
That's 79.9.
Perfect. That's okay. We're close enough. In fact, think about this here real quickly here. What 3 to what power gets you close to 80? Yeah, 3 to the 4th is 81, right? So that means this guy. Perfect. Yep. And then since we have a 2 here, it has to be close to 2, just a tiny bit shy of 2. Okay, example 5. Are we good? Does that make sense to you guys? And please punch into your calculators to make sure you get 1.994.
Are we going to use these on the test?
For a certain section, like this one right here, this one would be like, I want the exact answer, or I want the decimal approximation. So I think I'll put like little easier ones. I'll say I want to know the exact answer. The more difficult questions, I'll say round to the nearest 100th. Here's your calculator section. So there'll be 2 different sections on the test. There'll be calculator section and non-calculator section. Okay, example 5. Let's jam with. That was example 5. Example 6. Let me go back to E. Let's see if we can get this. Notice the 2 is not with the exponent anymore. The 2 is just sitting out in front as a multiplier. Perfect. So before you put in the logs, because you have a little 2 that's multiplying the E, we're going to divide by 2 first, because we want that E to the X by itself first before we do stuff. So now notice that the X is stuck in the exponent. X is stuck in the exponent. By the way, also grades are due today sometime. So if you have not turned stuff in, please do so. And by, let's see, I'll probably get home. So probably like 4 or 5 o'clock, I'll start grading things that have been turned in. So
I think this option got the midterm grades.
I think it should be next week sometime. Usually it's like there's about a week lag between when we're due and then when it goes out.
Are these the, like, their semester midterm grades where they have like all the columns and stuff, or are they midterm grades?
They're like our normal grades.
Midterm grades with comments. That's the
Final
usual.
grades are just
Okay, what do we do here? Anybody?
add an element.
Add an ln on both sides. ln here, ln there. Okay, and anybody? Want to tell me how to finish it off?
Can't you put the exponent in the front?
X1 in front, yeah, because of the power rule.
That's equals ln 50.
I go with that. Okay, so what we learn off of this one is the fact that if you have a multiplier in front, you gotta just divide out the multiplier. You want the base with the exponent value all by itself on one side before you start putting in the ln. Okay, that's 6, jam to 7. Okay, a little more complicated on the exponents. Let's do a little more complication here. I'm going to go with, let's see, 4 to the negative 3, t is equal to, oh, let's put some decimals in here now. That'd be cool. Okay, so I guess my first question is this. It's an exponent equation here. Is my base all by itself on one side? Yeah, that little 4, right? That little 4 sitting there all by itself. There's no multiplier to the 4, right? And so let's go for it here. I think I'm going to put in. Now, you could actually use ln if you wanted to, because remember, it's just a ratio between the two. Remember how the change of base formula? You could use base 10 or base e. It doesn't matter. So if you want to do this with ln's, it would still work. The only thing is whenever you see e as a base, you have to use ln at that point. So that's why in calculus class, and really in applications of life, we just start using ln's all the time. So then we don't have to think about, do I use log here or do I use ln? It's like, oh yeah, that's right, ln applies all the time. So if there's an e there, that's cool. If it's not an e, that's still cool. It'll still work. So ln's more versatile. But let's go with it here. So log, I'm going to still use this one here. And log on this side. Notice it's the same process, right? It's put in the log, multiply to the outside. And divide out by what you need to get rid of things here. In this case, negative 3. Log of 4. So negative 3. On your calculators, notice that you have a negative button and a subtraction button. Careful not to mix up those two. All right. Now I'm going to do my calculator. So log of 0.1 divided by a negative 3 log 4. What do you guys get for the answer there? Okay. Okay. Let's see, we've got 5 minutes to go here. Okay, let's do a toughie of these. So notice we've only done exponential equations. We haven't got to the logarithmic equations. When it starts off and it has a base and the x's and the exponent, those are called exponential. Okay, example 8. Dun, 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 dun. All right, this will be a toughie. I think we'll try this here because we've done all the easy ones now. This is ready. E to the 2x plus 9 e to the x plus 36 is equal to 0. Oh, man. Just one toughie for you.
We're not about to enter this.
Can't just enter it. Shucks. Yes, notice, class, notice you have this little x, technically it's x squared, isn't it? Hold on, let's rewrite this. Let's rewrite this together. Isn't this the same thing as this? Right, because it would power rule for exponents, right? If you're taking powers of powers, you multiply the powers. So I have that, I have that, I have that. And if I were to stick this back into algebra class, in algebra class, wouldn't this look like this? What two things multiply to 36, add to 9?
6.
And?
Oh, 6. Wait, no, it'd be 12 negative 3. No, negative 36.
Think so? I think we might be able to get away with it. I think. Let's see. 4. No, I think we are stuck. Are we stuck doing the quadratic formula?
It goes in negative 36.
Mhm.
12
12 and negative 3, huh? Bummer. I'm looking at this one here. I don't want to use the quadratic formula yet. Can we switch it up? I'm going to switch it up on you guys real quick here. If we use a negative, if we put a negative 36, would that work? Yeah, let's use it. Sorry, guys. Let me switch it up because I don't want to use the quadratic formula for this one.
So now would be 12 and negative 3.
Thank you. 12 and negative 3. Okay, that's the algebra portion, right? Let's bring this back to this. Because we have e to the x, we have e to the x plus 12 and e to the x minus 3. What do we know from algebra 1? What can we do with these guys? Because they're multiplying each other to give you 0.
The x equals 12 negative 3 negative 12.
So in this case, e to the x equals, oh, so hold on, back to algebra. Let's do this here. This one, we split them off, right? We say x plus 12 is equal 0, x minus 3 equals 0. Then you still have to move them to the other side, don't you? So then what we can do is we can just take the opposite, stick it to here. Take the opposite, stick it to there. We're good? Okay, minute and a half left. Let's go with it. So I have this, and then I have this. Agreed?
And now you can do the ln thing.
Now we do the ln. So ln e to the x is equal to ln of negative 12.
Yeah.
Putting the x in front. X is equal to ln of negative 12. Ha ha ha. Punch this into your calculator. I went into the nearest hundredth place.
Mine said not real answer.
Oh,
They were well made.
wow. How come?
Yeah, because
Can't be negative.
no, what would be an exponent? No.
So that would just mean that our only answer is 3. Or whatever it is.
Yeah. Remember, LNs only work with positive numbers, right? It doesn't even work with 0. So if you're at negative 12, sorry, there is no graph at negative 12.
The answer would only be x equals ln 3.
What's a good, yeah. So really, if you see ln of x equal to like a negative number, you can reject it right here. Like that's not possible. We're good? You can reject it down here. That's fine. This one gives you no solution. We do have to do this one here. So ln on one side, ln on the other, x ln of e cancels, and I only have one answer. X is a, so this would be the exact answer. So on test, I'm going to say, what's the exact answer to this? That would be it right there. Give me a decimal approximation to 3 decimal places.
0.98.
0.098. Okay, we are done, and we've only done exponential equations. We have not touched on the logarithm equation.